Welcome and hello. This is a video exercise in HEC HMS. And in this exercise, we are going to be investigating Introduction to Point Snowmelt Calibration. We're going to be working with a couple different snowmelt methods, specifically the temperature index method and the energy budget method for point snowmelt. What I have on the screen here is the first link in the description. So you can go ahead and click on that and follow along if you like. This is the first page of instructions where we're going to download the initial files, which is right here, and then get started with the step-by-step instructions. So go ahead and click download. That will download a zip file. All right, so let me close that. Let's see what we have in this folder here. It is Swamp Angel Point Calibration. Swamp Angel is the name of the project here. I'm just going to go up a level, find a place on my computer where I want to move these files, and then just wait for that to copy. Once that's copied, I can delete the zip file. And then let's go ahead and open up this project in HMS. All right, I got HMS open. I'm going to click open and then browse. Now navigate to that project. Here we go. And then click on this snowangel.hms file and select. All right, so if I open up the basin model, the only thing we have here is a single subbasin, and that's fine. There's still plenty of data already in this model that we're going to be using. Back to the instructions, if you scroll down a little bit, we have an introduction to the different point snowmelt methods in HMS. And then after that, we see introduction to the project. So this Swamp Angel location is in the southwest area of Colorado in the United States. And then we have some tasks, and now we start with the actual data. So we're going to be following these steps. I'm going to go ahead and just move this over here. The first step is to actually open up DSS View. So go ahead and download DSS View if you don't have it. Go ahead and click File, New. I'm going to save this in my data directory. Here is my project here. Here is the data directory. And then I'm just going to go ahead and give it a name, Snowmelt Swamp Angel.dss, and create. Okay, the file's been created. There's a little tab right here that represents the file. Next, what we want to do is retrieve the SNOWTEL data. This is snow depth, snow water equivalent, temperature data. So we go to data entry, import, and then we're going to go SNOWTEL right here. Now what we're going to do is set a start date of what it says in the instructions is October 1st, 2005. Okay. And then tab over to the end date. You can also click the ellipse and use the little ellipse tool calendar picker. So we're going to say September 30th of the following year, which is 2006, and okay. Down below, we need to select the different gauges or the SNOWTEL locations. So I'm going to go click by site and then filter by Colorado. Click OK. Wait for those results to load. There's 117 sites. So we'll click OK. Now what I'm going to do is sort by site number because I'm going to use Red Mountain Pass, which is number 713. So these are sorted by string instead of number, but it's all right because 713 is right here. If I make this a little wider, then we can see, yes, Red Mountain Pass. I'll click this checkbox here and then click this button at the bottom that says Import to DSS. That just takes a moment. We have 8 data sets that loaded for that time range for that particular location. So if I close that dialog box, here is our data. So it's 1 day data for that range. And then here in our part C, we see the different parameters. This snow water equivalent graph is what we're going to be most interested in for the next slide. We can go ahead and take a seat at what that looks like. Here it is, ranges from 0 up to almost 25 inches. If that comes 0, we next want to enter this time series as a time series data set in HMS and then reference it using this DSS path. All right, so let's go back to our HMS project. We're going to go up to Components and then Time Series Data Manager. For our type, what we want to select is this snow water equivalent gauges. Click New and then give it a name. All right, it's going to be SNOWTEL Swamp Angel. All right, that's steps 3 and 4 under Enter Time Series of Components if you're following along. Let's close that up and then go to the time series data and now snow water equivalent. Here's the time series data set we just created. So now we need to link that to the DSS file. To do that, we'll go ahead and for data source, select DSS. Now we'll select the folder icon and navigate to our project. All right, here's the project right here. And then in the data directory, We have our snowtel swampangel.dss file. And then as for the path name, if I click on the icon here, I want the snow water equivalent record and then click set path name. All right, and then I'll click save. Next, we want to assign this snow water equivalent of observed data to the model itself. I'm going to click on the subbasin here, which is up in my basin model icon. And then for this options tab in the components editor and observed snow water equivalent, go ahead and select our Snowtel Swamp Angel time series dataset and save. All right, so that was that step. The next task is to create and parameterize a new meteorologic model. So just scroll down and see here to this part right here. Back to HMS, we have our components, meteorologic model manager. We don't have any yet, so just click new, type in water year 2006, and then create. All right, let's go ahead and make edits to that. I'm going to expand the meteorologic models folder here, and then here is my MET model. Down in the components editor, we're told to include the US customary units here. And then for each of these different methods, it tells us to use the specified version. So for instance, shortwave, we want to use specified pyranograph. And then same thing for long wave. I'm just going to go ahead and do these for all the methods. Okay, so there's no evapotranspiration. That's step 4I, and then J says to set to default for any replacing missing values. All right, next what we need to do is associate our MET model with our basin. So I'm going to go ahead and click yes to these subbasins after clicking the basin model right here in the components editor. After I do that, I should be able to specify the gauge. So for specified pyranograph, the instructions tell me to use shortwave radiation. And then I'll just continue making these assignments according to the instructions. This is going to be long wave radiation. For the hyetograph, it's called precipitation. And save. All right, next on the instructions, we're told to choose a snow method. So what we're going to be doing in this exercise is option 1 and option 3. I do have option 2, the gridded hybrid snow method, covered in a previous exercise, but I want to deal with point source temperature index and point source energy budget. So let's go ahead and just open up a tab for option 1 and option 3. So let's go ahead and start with option 1 first, run through that, then do option 3. Option 1 is our temperature index method, so click on that. There's an introduction to this particular method right here, just mentioning that this is the simplest method that takes into account temperature. And now we're going to start by creating a paired datasets. I'm going to go up to Components menu and then Paired Data Manager. For the data type, I'm going to select ATI melt rate functions, new, and then I'll paste in the name ATI melt rate or type it in and create. While we're here, we also want a cold rate function. So that's the next one down, next type down, new, and I'll type in ATI cold rate and then create. Okay. Now we need to specify the actual data. So I'll click on pair data set. Here's my melt rate and cold rate here. Let's go with the melt rate first. This is just going to be a manual entry. So down here, I'll click on table. See the units are correct. That's good. And then I'll click on table and then enter the data that I'm told to in the instructions here. All right, that looks good. And then same thing with the cold rate. Those are the units. I'll click on table and then there is the cold rate values. All right. The next step is to parameterize the temperature index snowmelt method. So we're going to create a new basin and then click on the set the snow method to temperature index. And then after that, we're going to enter a bunch of data. So what that looks like is this. I'm going to go back up to basin model, click on Swamp Angel Basin, right click, create a copy. Then I'll just create a copy with the underscore TI suffix and then copy. Now that's the basin model I want to select here. So make sure you select that. And then I clicked on the sub-basin element right here or in the map. That's fine. And then what we want to do here is select a snow method for temperature index. All right, when we did that, we now have a snow tab right here. And this is where we want to enter all of our snow related data that starts on step 9 of this section. It tells us to leave the index blank. That's fine. It's not required. Right, so for PX temperature, this is 32, base temperature is 32, ATI coefficient is 0.98. I'm just going to go ahead and type all these in. All right, so I got all those values in right there. There are two drop downs. I should probably point out this ATI melt rate function. That's where we select our melt rate function that we just defined, and then same with cold rate. All right, so I'm going to go ahead and click save. The next step is to define a temperature index. So if we come up to the Watershed Explorer and then click on this plus symbol beside the subbasin, we have a temperature index as our snow method. Go ahead and right click and then add an elevation band. Then click the plus icon beside that and then single left click on the band. That way we can define the band parameters down here in the components editor. All right, so for part A, we're going to say percent is 100% because we're going to only have one band. So this represents the entire subbasin area. For elevation, it'll be 11,060 feet. For part C, we're going to leave that index blank. The initial snow water equivalent and all these other values are just going to be initialized to 0. The next step says to link the basin model to the meteorologic model. I think I already did that, but what that looks like is go to the Met model and then the basins tab here. And then, oh no, we had a new basin. Okay, so click yes to that. All right, looks good. We've already defined the Met model earlier, so we don't have to do that again. Next, we're going to create and compute a simulation run. So click on the Compute menu, Simulation Run Manager, New, and then for name, we'll call Water Year 2006 underscore TI, and then Next. The basin we want to select is this one here for TI because we have all of our temperature index data associated with this basin and the sub-basin in the model. Next, we only have one Met model and one control specification, so that's good. Let's double check the control specification, and it shows October 2 until the next September 30, so basically an entire water year at a 1 hour time step. I'm going to go ahead and save that, and then we're ready to run the simulation. We'll go ahead and make that selection, and then click Compute. All right, it's done computing. I'm going to go ahead and just look at the results real quick. View results snow melt graph. What we have in this plot is the Hyedo graph, precipitation depth at the top plot. The middle plot is air temperature. And then this bottom plot, this is the snow water equivalent. I forgot to link in the observed data. So one moment. I'm going to click on the subbasin and then options. And then I need to set Snowtel Swamp Angel data right there. Okay, let's see if that shows up in the plot. So snowmelt graph. Okay, I think I have to run the simulation again. All right, that's done. Now let's see if it's there. All right, cool. So this is what I was expecting. We now have a black line and a blue line. Black represents observed and then blue represents computed. Let me bring this up in a larger plot. So I'm going to click on the results tab, expand the simulation run, click on the subbasin, and then click on observed snow water equivalent. Hold down control, snow water equivalent. Oops, wrong one. There it is. And then click on this graph button up here. I'm going to modify the colors real quick. So I do edit plot properties. I'm going to make the red line a little darker or thicker. And then the other line, I'm going to make that blue a solid line. And then I'm also going to make that a little thicker. Apply. Okay. Here are my plots. So we can tell for the first, I don't know, half of the year almost, we have a really good match between the observed and computed. And then after that, the computed is too much snow water equivalent for, I'd say, starting in April or so. So we need to make a few parameter adjustments to make this blue line look closer to the red line, i.e. less snow water equivalent for April, May, and June. All right, one other thing to check out is if you click on the subbasin tab and then click on this summary table, we can look at the statistical metrics such as Nash set cliff and percent bias when comparing the observed and computed snow water equivalent values. After that, the instructions tell us to calibrate the temperature index parameters. So what that means is go back to the subbasin, click on the snow tab, and then modify some values. And it's giving us some suggestions here. Step 1 tells us we should modify the temperatures. And then step 2, the melt rate values. So I'm just going to go ahead and make some edits, run the simulation a couple more times, and then look at the results. All right, so I'm going to click on the subbasin here. Here's the snow tab. If we had too much snow water equivalent the first time, I suggest we decrease that temperature just a little bit, and then that should result in a little bit less snow water equivalent. So I'm going to go 30, 30 for both the PX temperature and the base temperature. Save it, run it again, and then let's check out our results. I'm just going to go ahead and right click and Snowmelt graph. Okay, this looks like a stronger correlation right here. And then let's take a look at the statistical values. We have 0.968 as well as 3.81%. I'm going to go ahead and bring this up in the main plot, the bigger plot, observe snow water equivalent, and hold down control, snow water equivalent, open up the graph, update the colors. And yes, it looks like we still have too much computed snow water equivalent, but we're getting closer. Another thing the instructions tell us or suggest for us to change is the melt rate. So instead of changing the air temperature again, which I think is plenty low at 30, this melt rate function right here, which is defined in the paired data manager down here, let's go ahead and modify these values by clicking on table. And then what I'm going to do is just double the values and see what happens. All right, with those values changed, let's go ahead and run the model once again. All right, and then let's right click and Snowmelt graph. Okay, looks like we probably underpredict a little bit. I'm going to take a look at the summary table, 0.945 and negative 9.17. And then here is the plot that we saw before, except we're only getting closer. It looks like we're under predicting a little bit for the first few months of the water year. And then on this receding limb, it looks like we under predict, but just by a little bit. What I'm going to do is change the temperature back up to 32 degrees and see if that makes any difference. So I'll go back to the subbasin snow tab. We're going to leave that melt rate function as it is, doubled from the original, and then just change these temperatures back to 32. Okay, I'm going to click save and then compute, and then that's done. So let's go to I'm going to click on the subbasin, click on the summary table, and then these are definitely our best numbers yet, less than 1% on percent bias, and then Nash-Sutcliffe value is almost up to 1. If I click on the results tab, let's go ahead and check that out. We have observed snow water equivalent, click the graph plot, and then here is our final plot with that fourth trial. Looks like we may have overpredicted here, but if we had more time, we could go ahead and maybe even get closer to that observed hydrograph. Well, that's it for the temperature index method. It just leaves us off there. We can download the final project files if we want. But let's go over to option 3. This was the energy budget method. And we're going to follow these instructions to do some similar, but although different tasks from temperature index. So what we're going to do is start by creating a new basin model. And then for the snow method, use the energy budget snow method, and then set up the initial parameter values. So I'm going to click on the Components tab and then go up to the basin. I'll just select this default basin, the first one, create copy. And then this is going to have an underscore EB suffix for energy budget. Okay, so expand that right there. I'm going to click on the subbasin itself. And then for the snow method, it's going to be energy budget, save. For the snow tab, now we need to set this information here based on the data in step 9 of the instructions. Precipitation index, I'm going to leave that blank. The rain threshold will start at 32. The snow albedo value, 0.95, and the new snow, 0.50. Okay, so I got those numbers in there. Next, what we want to do is add an elevation band. Just as before, we'll go ahead and right-click on our snow method. And then what did we do? Add elevation band. Click on that band. We have to expand the energy budget icon. I sometimes call it energy balance, but it's energy budget. I was confirmed. We need to specify this elevation band data. We're only going to have one band. So again, we're going to say it's 100%. This is down in step 12 now of the instructions. So I'm just going to fill out the rest of the data. The elevation is the same. And then all of this data is pretty much zeroed out because we're starting at the beginning of the water year. Okay, so those are the values there. And then I'll click save. Because we have a new basin model, we want to go ahead and set that meteorologic model to use this basin model as well. So here's the MET model, basins tab. Let's change this no to a yes. So we're good there. And the next step is to create and compute a simulation run. So I'll go to compute, simulation run manager, new. I'm going to go ahead and give this a name with the underscore EB. Next. And we want to use that basin we just created. Next, next, next. All right, there's our run. Let's go ahead and select that run and then click the compute button. Okay, there's an error. It says could not locate the observed snow water gauge. Okay, so I forgot to do that again. 1 second. And then click on the subbasin icon. And then in the options tab, again, I need to set that Snowtel Swamp Angel observed snow water equivalent time series data set. Okay, let's see if that runs. Okay, that ran. Looks good. And then just as before, let's view that graph and summary table. Oops, where's the snow data? Oops, okay, now I'm missing snow data. 1 second. Swamp Angel. Okay, I was actually editing the main Swamp Angel basin, and I'm just going to go with that. So what I want to do instead is just modify my simulation run here to use the basin model that actually has my snow data associated with it. Okay, so that's not part of the instructions, but I'm just trying to, I just don't want to waste anyone's time here. All right, let's run that once again. All right, and now we should be able to view the snow melt graph. All right, just as before, this blue line is over predicting the observed snow water equivalent. And what the instructions tell us to do is to go into the snow tab for this subbasin and then modify the rain threshold air temperature, snow threshold air temperature, new snow albedo, as well as the min snow albedo. So that's these fields here and then these two fields down here. Since we have too much snow water equivalent, again, I suggest we drop that temperature down from 32 to 28. So let's do that. And then I'll just change both temperatures and then click run. Okay. Let's go ahead and look at the results on this right here. Observed snow water equivalent, snow water equivalent. Okay, this looks like a pretty strong match, actually. I'm going to click the graph button right here. And then here I added the colors. Looks like we're doing very well. In fact, we probably underpredict for the first couple months of the water year, and then pretty much an exact match around March. And then it looks like we're over predicting. The computed results are a little bit more than observed right here for the month of April and May. All right. What we could do now to decrease that snow water equivalent later in the year is to decrease the snow albedo. So what I'm going to do is go to subbasin and then the snow tab here. We have new snow albedo and min snow albedo. I'm going to go ahead and change the new snow albedo down to 0.75, which is quite a bit lower, and then just run the model and see what happens. Okay, I've been forgetting to look at the Nash-Set Cliff scores, but we're up to 0.947 and then negative 6.6%. And then here is the plot that we've been looking at. Very strong. I want to make one more minor adjustment, and that is to increase the minimum snow albedo value just to see if we can make any minor improvements. Right here is really the area that we need to focus on, and maybe a little bit down here. I'm going to click on the snow tab again. I'm going to increase this to 0.55 and then hit save and compute. I'm just going to go straight to the summary table. I can also get the summary table by going right click, view results, summary table right here. Now we're up to 0.963. So that's a small improvement and then negative 3.79% under on the percent bias. I'm going to look at the plot now, results observed versus computed. Click the graph, fix the colors, and I mean, to me, this pretty much looks the same as the last one. So it looks like a pretty good plot, looks like a pretty good fit, and it's a good introduction exercise on the different point snowmelt calibration methods. We did temperature index as well as energy budget methods.